Okay, our topic today is multiplying small numbers. Now we're mostly going to focus on mental strategies, but before we get to that, there's a couple of other things that we need to talk about that will help us do this. So the first thing we need to think about is a term that you need to know, and that is the word product. And the word product is the answer to a multiplication problem. So anytime I'm talking about a problem, I say, what's 5 times 3? What's the product of 5 times 3? That's 15. It's the answer to the problem. Now, we're also going to talk about the commutative law. We've talked about this in the context of addition before. But the commutative law says that when we're multiplying two numbers together, it doesn't matter what order we put them in. We write it A times B is the same as B times A, but you can think about it with numbers that you know. 5 times 4 is 20, just like 4 times 5 is 20. It doesn't matter what order you put it in. 3 times 2 is 6, 2 times 3 is 6. Doesn't matter the order. Closely related to the commutative property is the associative property. And the associative law, or property, says that even when we have brackets, if they're all multiplication, it doesn't matter where the brackets are. And we write it this way. A times B, in brackets, times C is the same thing as A times B times C, in brackets. So, for example, let's say that we had 2 times 3 times 4. We could say 2 times 3, which is 6, times 4 is 24. Or we could change it and say 2 times 3 times 4, 3 times 4 is 12, and then multiply times 2, we still get 24. As long as they're all multiplication, it doesn't matter where the brackets are. Now, when we're dealing with multiplication of relatively small numbers, one of the things that we will often use is an algorithm. And just like with addition, algorithms need to be vertical, and the columns need to be nicely lined up. So, for example, 23, we'll write that here, algorithm. 23 times 4. And the algorithm method says we multiply 3 times 4, which gives me 12. I write down the last number, and just like with addition, I carry over anything that's left over. So 3 times 4 is 12, the 2 goes there, and the 1 goes up here. I carry it over, and then I multiply 4 times 2, which is 8. And I add, not multiply, I add the 1 on. So 4 times 2 is 8, plus 1 gives me 9, and I have 92. Now, as I said, I want to focus largely today on mental strategies for how to do some of these numbers. Now, we're going to erase part of this so that we have a little more space to work here. One of the first things that you can use is the idea of times tables. So, times tables, blast-off sheets, any of those methods that we use to sort of help you learn your multiplication. We don't want you, if we say, what is 7 times 3, we don't want you to have to pull out a calculator or even write down an algorithm to do 7 times 3. 7 times 3 should pop into your head 21 immediately. So, one of the mental strategies is learn your times tables. And the commutative law and the associative law in combination can help you with this. So let's say, for example, that we had a problem like this, 43 times 2. Now, that might be a little harder. If it helps you, you can always use the commutative law and change the order. 2 times 43, and maybe that makes more sense to you and you can recognize that that's 86. Okay? That's one mental strategy you can use. Another mental strategy, as I said, is using the associative and the commutative laws together. So, for example, if we had 55 times 20, we can break those up. 55 is what? What do you think of when you think of 55? Well, we think of maybe 5 times 11. And then we say times, and 20, probably one of the quickest ones you'd think of would be 2 times 10, right? 2 times 10. Now that still doesn't look like an easy problem, but let's change the order around a little bit. We're going to put 5 times 2 at the beginning, and then we'll put in times 10, and then we'll put in times 11. And if you practice these a few times, you'll sort of start to recognize patterns, and you'll know what order to put them in. Here we have 5 times 2, that's 10. And then we have times 10 times 11. And we all know 10 times 10 is 100. Times 11, which gives me 1100. Or 1100. Which you might be able to get from this, but if you can sort of do this mentally, break it apart, put it back together in a way that makes more sense, it'll be easier for you. Now, one of the other processes that's kind of important to learn is the idea of squared. So squared is where we take a number and multiply it by itself. So for example, 3 squared, if we write like this, 3 times 3, and the way we write that is 3 squared, and 3 squared is 9. And as you go through mathematics, it's really helpful to know these kind of numbers called a square number. Numbers that are formed by multiplying the same number by itself. And the basic square numbers, as you go through mathematics, it will help you if you can learn all of those. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 81, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. If you can get those in your head, even 11 times 11 is a 121, 12 times 12 is 144. If you can keep those in your head, it will help you with a lot of mathematics as you go further in mathematics. Okay, now these are some of the basic ideas. Now I'm going to talk about 3 more things that are related to some of the things that you know about mental strategies in addition and subtraction. The first one is what we call the distributive law. And I'm actually going to erase this so that we have a little bit more room. So if you haven't got this yet, then you're going to want to pause and copy it down. The distributive law is written like this. We say A times B plus C is equal to A times B plus A times C. Or, another way to say this is A times B plus C. It's the same thing as A times B plus A times C. Now, that might not make a lot of sense to you that way, but let's think about it this way. Let me give you an example of how you might use this sort of a problem, this sort of a shortcut, okay? So if we had 6 times 21, you might be able to do that in your head, but an easier way to think about it is this. 21 is what 2 numbers added together, 20 and 1, both of which are pretty easy to multiply by 6. So what we're going to turn this into is 6 times 20, and then we're going to add 6 times 1. Okay? We've just taken 2 numbers that add together to 21, and then we do them like that. So 6 times 20 is 120, and 6 times 1 is 6, and so we get that our answer is 126. Now you can do the same thing with subtraction. So here's an example. Let's say 7 times 18. Now 7 times 18 is not a particularly easy problem, but how about if we said, well, 18 is almost 20. 18 is 20 minus 2, right? 18 equals 20 minus 2. So we're going to make this 7 times 20 minus 7 times 7 times 2. So then we have 7 times 20 is 140. And 7 times 2 is 14. And when we take 14 away from 140, you might need an algorithm to do that. Or you may be able to do it in your head. If you can do it in your head, you would see that that was 126. Okay, it just happens to be the same as the other one. Now I'm going to do a couple more examples of these. Here's another one. Let's try 3 times 13. Now you may be able to do that in your head, but here's a way to help you sort of pull it apart and then do it. This is 3 times 10 plus 3 times 3. 3 times 10 is 30. 3 times 3 is 9. You do them together and you get 39. Again, I'll give you a subtraction example. Let's try 4 times 29. Well, 29 is sort of a hard number, but we could say 30 minus 1 is 29. So we're going to do 4 times 30 minus 4 times 1. 4 times 30, 120. Minus 4 times 1 is 4. And we get our answer, 116. Okay? Now, also, I'm going to erase this. You may want to pause. Two more mental strategies. One is called doubling and halving. So doubling and halving refers to changing some of the numbers, doubling one and halving the other to get numbers that will work more easily. Let's try this example. 5 times 7 times 4. Now those numbers aren't all terribly easy to multiply together, but let's make it easier. So we're going to double the 10 and cut the 4 in half. And we'll notice they're both times, so that's okay. We're going to make the 5 a 10. We doubled it, times 7. And we're going to cut the 4 in half because we doubled and we halved. Now we have a much easier problem. 7 times 2 is 14. And so then we have 10 times 14, and that gives me 140. Okay? Let's use another example. Let's say we had this problem. 5 times 24. Now that's a very good example. All we have to do is double the 5. That makes it 10, which is always easier to multiply. And since we doubled that, we're going to cut that in half. Half of 24 is 12. Now we have 10 times 12, which is 120. And that is the doubling and halving method. The last method that we're going to use for mental multiplication is called factors. As you may remember, factors are numbers that multiply together to give us another number. So for example, 12, two of the factors of 12 are 3 and 4. We could do 3 times 4 gives me 12. Or we could say factors of 12 are 2 and 6. 2 times 6 is 12. So here's an example. Let's say I had 11 times 12. Well, there's not much we can do with the 11, but the 12 we can make a little bit easier to deal with. So what we're going to do is we're going to make it 11 times 2 times 6. Okay? Now we have 22 times 6, because 11 times 2 is 22, and 22 times 6 is a lot easier number to deal with, and that is 132. Okay? You might have found that one a little bit challenging. Let's do one that I think you might find a little bit better to use. 7 times 14. Now those numbers are not real easy to multiply together, but what do we know about 14? It's 7 times 2. So we have 7 times 2. 7 times 7 is one of those numbers that I said you need to keep those really quickly in your brain. It's a square number. 7 times 7 is 49. And 49 times 2 is much easier to do. You might want to use one of these other things to help you with that one, but 49 times 2 is 98. So that is multiplying small numbers.